The next thing we're going to look at is the area of a sector. And so, based on my diagram to the right, we see that this shaded blue region is the sector, is called a sector of a circle. Okay. Now, by definition, this sector is a portion of the total area of the circle. Very similar to how arc length is a portion of the total circumference. So to determine how much of the area is represented in that shaded region or in that sector, first thing we need to do is find out what the total area of the circle is. And formula for area of the circle is pi r squared. Now my radius is 8. Okay, so remember, order of operations, we do exponents before we multiply. So this is going to equal, and 8 times 8 is 64, so this is equal to 64 pi. Or, let me get my calculator. 64 times pi is equal to 201.06, or we'll round it to 0.1. Now, unfortunately, this diagram doesn't have units. We'll just say it's inches. Okay, so this is inches. So the total area, so if the radius is 8 inches, the total area of the circle is 201.1 inches squared. Okay, so that's the total area. So to find what the area of just that sector is, we're going to do the same thing we did with the arc length. That sector is represented by 60 degrees of the total 360 degrees in the circle. So remember my fraction part to whole, or part to total. So to determine what portion of the total area that represents, I am going to multiply 201.1 times 60 over 360. Now, for the most accurate answer, I'm going to multiply the fraction times the total area. So I'm going to do 201.1 times 60, and I get 12,000 66 when I multiply straight across. And of course 1 times 360 is 360. So to take that 12,066, I'm then going to divide it by the total number of degrees 360, and I get 33.5 inches squared. Now you can do the division first. You can do 60 divided by 360. And when you do that, you get 1.666 repeating. Now that's why in this particular case, because 60 divided by 360 is equal to 0.166 repeating, when you round that off, you are compromising the accuracy of your answer, because by dividing 12,066 by 360, the calculator's taking it to 8 decimal places. So you run the risk of not getting the most accurate answer when you round off that 1.66. But that is so that the area of that sector represented by 60 degrees of the total 360 is 33.5 inches squared. And if I was to, just to show you that obviously the math works, if I do 33.5 and I divide that by 201.1, so the area of the sector over the total area, so 33.5 divided by 201.1, when I do that, this equals 0.166 repeating. So we have calculated this correctly because this 33.5 represents the 0.166, which is equal to the 60 degrees of the total 360. Okay. Next, we're going to take a look at what we call inscribed angles. Okay, now, inscribed, we talked about central angles. So in our problem with area of the sector, that 60 degrees is a central angle because the vertex is at the center of the circle. An inscribed angle is formed by two chords. Okay, now remember, a chord does not go through the center of the circle. A chord just goes from one side of the circle to the other without going through the center. And you'll notice that in question 20, those are inscribed angles, okay? Because each of these is a chord that does not go through the center, and the vertex is actually on the circle itself. Okay, so an inscribed angle is formed by two chords. Number 19 asks, what's the relationship between the inscribed angle and the intercepting arc? Okay, so erase this. Okay, so if my inscribed angle is, my inscribed angle is here, okay, and the intercepting arc is where the two chords, the end of each chord, where they meet. So NP, so angle M creates the intercepted arc NP. And the relationship between that angle and that arc is half. Okay, the inscribed angle is 1/2 of the arc. Now I have a separate video that explains why geometrically this is the case. And that's a whole nother proof that I don't want to spend time going into here. So if you want to check that out, please take a look at that on my YouTube channel under Circles playlist. So knowing that the angle is half the arc, if NP is 100 degrees, that means angle M is 50 degrees. It's half. Okay? Now looking at example B, we're given the angle instead of the arc. Okay? And in that case, if the angle is half the arc, to get the arc, we would multiply times 2. So 115 times 2, that arc ZWX is 230 degrees. Okay, so if you're given the arc, your angle is going to be half. If you're given the angle, you need to multiply times 2 to get the arc. Okay, so I'll go through problem C with you, and then you can try D. Okay. So we're looking for arc AC. Okay, so AC is here, and it's formed by angle B. Well, angle B is 55 degrees. So if my angle is 55, that means my arc AC is 110 degrees because I multiplied times 2. Okay. Now, arc AB. Okay, if you notice, arc AB forms a semicircle because AB, now I've kind of highlighted things a little too much, AB is a diameter. So arc AB is 180 because it's half the circle. And then BC, angle BC, okay, so if we know that AB is half, to get arc BC, we can just do 180 minus 110, okay, because half the circle is 180. Well, from A to C, we already know that's 110 degrees. So that's going to give me, when I do 180 minus 110, that tells me that BC is an arc of 70. Now, next it now asks me for angle A. Now, if you notice, BC, okay, this arc here, intercepts to angle A, okay, and A is an inscribed angle, partially formed by a diameter, but the AC is a chord. So angle A is going to be half arc BC. So half of 70 is 35. Okay. And then, again, let me do a little more erasing here because it's a little messy. Okay. So we know this is 35. And we knew this was 110. The arc was 110. And this is 70. Okay. So then the question is, what is the measure of angle C? Well, if you notice, AB and C is actually a triangle, which has a total, any triangle has a total of 180 degrees. So if I do 55 plus 35, which is 90, and so subtract 35 degrees, subtract 55 degrees, that leaves me with 90 degrees. So this is actually a 90-degree angle. Okay. Try part D. Pause the video, see if you can answer all of these. Sorry about the dogs. Okay, so for arc WV, you should have multiplied 42 times 2 because the arc is double the angle, which would give me 84. Then arc XY, V, okay, again, XV is a diameter, so that's 180. WX, okay, so you notice we have the diameter here. WV is 84, so WX would be just 180 minus 84. Giving me a total of 96 degrees. And I need to erase this a little bit because I'm having a hard time seeing my circle here. And XW creates angle V. So the inscribed angle is half the arc. So that's going to be 96 divided by 2 to give me angle 48. And again, I have a triangle. So 180 minus 42 minus 48 gives me 90. So angle W is a 90-degree angle. So question 21 asks us, what conclusion can be drawn about the angle formed by two arcs that intercept the diameter? Okay, so two arcs, that would be XW and XV. They both intercept the diameter. That same thing with angle C. BC and AC intersect to create that diameter. Now if you notice that diameter is 180 degrees. So that intercepting angle is going to be half of that. So you're always going to get a 90-degree angle anytime that happens.